Howdy, my name is Nick O'Connor with the Texas A&M University Industrial and Systems Engineering Capstone Senior Design course. Our team consists of Young Cho, Nathan Johnson, myself, and Tien Duong. Our project is sponsored by Halliburton to carry out an inventory and demand analysis for Halliburton's casing facility in North Houston. The casing facility designs and builds custom casings which are procured on an as-need basis. This makes forecasting the demand of casing components difficult and often leads to financial loss. The combination of services, including design builds and casing maintenance, creates the need to have components stocked in inventory. However, creating an appropriate inventory level is easier said than done, as the casing facility has experienced a 97% demand increase in 2017 and is already expecting an additional 15% demand increase in 2018. To assist Halliburton in meeting casing demand in 2018, Halliburton needs a list of critical components to be analyzed. They need minimum order quantities, or MOQs, for each component. They need documentation of the processes and methods used to create an MOQ model. And finally, they need a financial analysis for the impact and risk of ordering the recommended minimum order quantities. Casings are finished goods which are composed of many components, such as couplers, equalizers, and cement. Many of these components are also composed of subcomponents, the breakdown of which can be deduced by analyzing the bill of materials. Using the bill of materials, materials are broken into subassemblies and then into the most basic components. Many iterations of this procedure is conducted to create a list of most basic F components. These components are then cross-referenced with shipping and scale pricing data to ensure the most basic F components were shipped in 2017 and that they receive a quantity discount from vendors. These criteria were used to create the list of critical components. With the list of critical components in hand, MOQs need to be set for each component. MOQ models minimize an annual cost function that optimizes an inverse relationship between the cost of lost sales and inventory holding costs. However, typical MOQ models assume constant purchasing costs and cannot accommodate scale pricing. Therefore, the quantity discount model is used, which outputs the annual cost associated with ordering every price break quantity awarded by a vendor. The MOQ is then set as the quantity with the lowest annual cost and will be ordered when the respective inventory reaches a critically low level. To ensure the longevity of the model, documentation of the steps taken to forecast demand and calculate MOQs was requested by Halliburton. To assist training of relevant personnel, videos documenting step-by-step procedures to create the model were recorded. The documentation is intended to be used for understanding as well as to assist the recreation of the model at a future date when market variables change. To justify the model, a financial analysis was conducted by running the model to suggest order quantities for the first 9 months of 2017. The actual demand is known, as well as Halliburton's total cost of purchasing critical components in that time period. The model predicts that only $12.2 million would be needed to satisfy demand, while Halliburton spent $14.4 million to satisfy the demand. The financial analysis suggests that Halliburton would have saved $2.2 million in the first 9 months of 2017, which is a 15.26% decrease in spending. It has been an honor working with Halliburton on this problem, and on behalf of our team, I thank you for your time and hope you enjoyed this video. Thanks, and gig 'em.